All right, welcome back for Chapter 4, Ratios, Proportions, and Similarity. And today in Lesson 3, we're talking about similar figures. So, similar figures have the same shape, but not necessarily the same size. So I really like this picture right here because this shows similar, I'm sorry about that. I kind of moved it. Kind of move it back, move it back, move it back. Okay. This shows similar figures. So we have the A, right? And it's all the same shape, but they have different sizes, right? This is a 12 point, then 24 and 48 and 72 and such. So I think that this is a very, very excellent illustration of what similar figures are. They have the same shape, but not necessarily the same size. So similar figures have two characteristics. The first thing is that they have the corresponding sides of two figures are in the same relative position, okay? So the first thing is with the corresponding sides of two figures in the same relative position. And then corresponding angles are in the same relative position. So we're going to look at a couple of examples so you can see what this is referring to. So for polygons, right, polygons is many-sided. Poly means many, shapes, many-sided shapes. For polygons to be similar, you must have corresponding angles must be congruent, okay? So corresponding angles must be congruent, and the corresponding sides must have lengths that form equivalent ratios. All right, so let's go ahead and look at that. So we have this figure right here, okay? So we have two triangles. So we want to see if they're similar. Now, when they are similar, they have this little thing here, and I'll write it bigger so you can see. This says triangle ABC is similar to triangle DEF. Okay, so this is ABC and this is DEF, and it says that they are similar, which means they have the same shape but not necessarily the same size. So whenever you have something that's similar, right, for polygons to be similar, the corresponding angles must be congruent. Okay, so let's go ahead and see that. Now, corresponding angles would be the angles that match up. So right here, if you look here, B and E, those angles are 120, right? So we can say the measure of angle B equals the measure of angle E. Now that one's really, really easy to look at the picture and see. Now here we have two 30s, right? So which one's which? So I like to go back to here. So when we have this information, this actually tells us all of the angles that are similar. Okay, so this first letter and this first letter, A and D, those are corresponding angles. So we know that the measure of angle A is equal to the measure of angle D. Okay, now what letter's next? B and E. Those are corresponding and they're the same, right? B and E, we have that one. And then the third, the letter that's the third, C and F, C is 30, F is 30. Those are corresponding angles as well. So whenever you write this, let's say you have two similar triangles, you have to write this symbol very, very carefully because the order matters in how you write this, because A and D are the same, B and E are the same, and C and F are the same. So in order to show this, you have to make sure that the corresponding angles are written correctly in this statement. Okay, so that's the corresponding angles must be congruent, and we have that. Now for them to be similar, the corresponding sides must have lengths that form equivalent ratios. Now when I say equivalent ratios, that's like means the same, and ratios is talking about fractions, right? So this statement also tells us these corresponding sides which are which correspond to each other. So the first one I'm going to look at is going to be these first two letters. And it's so cool because it tells you in this. So first two letters is AB. Okay, so AB corresponds to DE. All right? And that is a ratio. So I can say AB over DE. Okay? Now, that is the same, okay, as, let's see, okay, so we did the first two letters. We can do the last two. So BC corresponds with the last two here, EF. So it just illustrates on how important it is for you to write this similarity statement correctly. Okay, so BC over EF. Those are corresponding sides, and they're equivalent ratios, all right? Equivalent fractions. And then there's the last one, which is the first and the third. So AC, okay, I think I'm gonna use pink. I'm trying to figure out what color to use. So AC is the first and third, and then DF is the first and third here. Okay? Okay, so AC and DF. Now, this says that the corresponding sides must have lengths that form equivalent ratios. So that's what it says, but let's go ahead and figure out if it's true, okay? So when we look at AB, AB is 3. What is DE? DE is 12. Okay. Let me move this up a little bit. Okay, so let's see, 3/12. Perfect. I mean, we can reduce that, right? What goes into 3 and 12? 3 does, right? And then the question is how many times? Well, 3 goes into 3 one time, 3 goes into 12 4 times, so we're left with 1/4. Okay? Now let's do this one here. So BC, let's do this next one, see if they're the same. BC is 3 over EF is 12. Okay, and we just figured out that 3/12 is the same thing as 1/4, right? What about this last one here? AC is 6 and DF is 24. Okay. What goes into both? 6. 6 goes into 6 one time, and 6 goes into 24 4 times, and so it is 1/4. So you see, they do have equivalent reduced ratios there. So they have corresponding angles, which are the same, and they also have corresponding sides that have equivalent ratios, and that's how we know that these two triangles are similar. Okay, similar means they have the same shape, but not necessarily the same size. All right, perfect. Okay, let's go ahead and look at a couple examples. Okay, so this first example here, what we're going to be doing is identifying similar figures. So which triangles are similar, all right? So just looking at this, right, you need, we need triangles that have, I think the easiest thing to see are the ones that have the same angle measures, right? So when I look here at these two triangles, they both have 80, right? They both have 60, and they both have 40, all right? So I would say, right, for them to be similar, they need to have corresponding angles. So that's the first thing, corresponding angles. Okay, so we have the measure of angle A is equal to the measure of angle A prime. The measure of angle B is equal to the measure of angle B prime. And the measure of angle C is equal to the measure of angle C prime. Okay, so we have the corresponding angles. That is perfect. Now we just need to check the corresponding sides. Okay, corresponding sides, Okay. All right, so that would mean, so A and B, between A and B, those would be corresponding sides right here. Okay, that's between the 80 degree and the 60 degree angles. That side corresponds. So I'm going to say, let's go AB over A prime, B prime should equal, let's do the next one, which is between, let's do this one, 60 and 40, BC. This side, which is also between 60 and 40. So I like to use those angles to make sure, 60 to 40. So I wouldn't choose the side between 80 and 40 because I need the side that's between 60 and 40 degrees, which would be this one here. So those are corresponding sides. I have to make sure that I put this, so this one I'm putting on top, this one I'm putting on bottom. So top, bottom, you have to follow that same pattern. BC equals, over B prime, C prime. And then lastly, AC here and A prime, C prime. Okay. AC and A prime, C prime. So let's go ahead and fill in the numbers and see if they are similar. Okay, so what do we have? Okay, so AB is 2 over 4. All right, and then BC is 4 over 8. And then AC is 3 over 6. So I think we just need to reduce these fractions and see. Right now they don't look the same, but let's go ahead. I think these can be reduced into simplest form. So 2 and 4, 2 goes into both. 2 goes into 2 one time, 2 goes into 4 2 times, so we're left with 1/2. What about 4/8? Well, 4 goes into both of those. 4 goes into 4 one time, 4 goes into 8 2 times. We're left with 1/2. Okay, that's great. Those are equivalent ratios. And then here 3, 6, what goes into both? 3. 3 goes into 3 one time, 3 goes into 6 2 times, and we're left with 1/2. Okay, so they have corresponding angles which are the same, and they have equivalent ratios for their corresponding sides. So we know that these two triangles are similar. So we can say triangle ABC is similar to triangle. Now this is very important the way you write this, right? So you have to put the angle which is the same as A. So we know that A and A prime, and then B, you have to have the same angle, which would be B prime, and then C prime. And so we know that those two are similar triangles. Okay, now let's look at this other example here. If we look here with these triangles, we know that these are not similar because nothing has an 80, right? So these triangles aren't similar, but could they be similar to each other? Let's look. So this angle here, 94.22, 94.22, that's the same. 45 is the same as 45, and 40.78 is the same as 40.78. So far, we have corresponding angles, which is, one step in the right direction, right? So let's see here. We're going to say corresponding angles. Okay, so that is going to be measure of angle A. Measure of angle A is equal to 45 is equal to D. Measure of angle D. I'm going to say B. Measure of angle B is equal to measure of angle E, and measure of angle C is equal to measure of angle F. Okay, so that's perfect there. Now we have to check the corresponding sides. Okay, so I'm going to try the side that is between 45 and 40.78. So that's AB over 45 and 40.78, that would be DE. Okay, so I'm going to say that those are corresponding sides. These two are between those two angles. The next one I'm going to look at is going to be the one between BC, so 40 and 94. So BC and 40 and 94 would be right here. EF. So BC over EF. And then lastly, AC and DF. AC and DF. Okay, now let's go ahead and plug in those, substitute in those numbers and see if these corresponding sides have the equivalent ratios. So AB is 6 over DE is 18 equals BC is 5 over EF is 15. AC is 3 over DF is 9. Okay, now it just looks like we need to simplify these ratios. So 6, 18, they have a common factor of 6, right? 6 goes into 6 one time, 6 goes into 18 3 times. So we are left with 1/3. 5 fifteenths, 5, they have a common factor of 5. 5 goes into 5 one time, 5 goes into 15 3 times, so we have 1/3 again. And then 3 ninths, is there a common factor? Yes, 3. 3 goes into 3 one time, and 3 goes into 9 3 times, so we have 1/3. So since we have our corresponding angles and that are the same, and our corresponding sides have equivalent ratios that are all the same, we know that these two triangles are similar. So I'm going to say, I think I'm going to draw a line across this because I don't want this to get these two confused. I have ABC and then I have ABC. So I'm just going to separate these two. So we know that this is going up here. This triangle ABC is referring to this information. And then down here, we have triangle ABC is similar. A, right, to triangle, and then we have to have the angles match up. So A is with D, and B, 40.78, is with E, and lastly, C is with F. And there we have it. Those two triangles are similar. Okay, perfect. Let's go down to B. Now B is kind of fun because we aren't dealing with triangles. We are dealing with, these look like rectangles, so four-sided figures, right? And four-sided figures can be similar as well. So let's go ahead. They need the same characteristics. They have to have the same angle measures, but, and the same angle measures and what else? Same angle measures, and the sides have to have equivalent ratios. So that leads us to that same shape, but not necessarily the same size. Okay, perfect. Let's go ahead and get started. So just by looking at these, obviously I'd want to look at the angles, right? That's the easiest thing. Well, this means 90, 90, 90, 90, 90, 90, 90, 90, 90, 90, 90, 90, 90, 90, 90. So they all have the same angle measures, right? So corresponding angles, they're all congruent. So what we're going to look at are those corresponding sides. Okay, so that's where we're going to start, is with the corresponding sides. So let's start here, corresponding sides. Okay, and let's just take these two first. So I'm going to take AB, and that's the long side, and this is the long side. So let's go AB over WX. And we're going to see if that is the same thing as BC over XY. Okay, we're going to see. So what is AB? AB is 28, and WX is 21, equals BC is 16 over XY, which is 12. Okay, so now we just need to reduce. So let's see here. What goes into 28 and 21? Well, 7 does, right? 7 goes into 28 4 times, and 7 goes into 21 3 times, so we end up with 4/3. Okay, okay. What about here? What goes into both 16 and 12? I'm going to say 4 does, right? 4 goes into 16 4 times, and 4 goes into 12 3 times. Okay, so we have a similar ratio there. Perfect. So that means since they have the same angles and they have the same equivalent ratios, that we know that these two are similar. Okay, so we know that, so this is yes. I'm just going to give this a yes. Okay, but let's see if there's any other figures that are similar. How about we look at these two right here. So I'm going to look at AB. Let me get a different color. Let's go purple. So let's go to AB over GH. And then let's see if that is similar to BC over HJ. Okay, let's substitute in those numbers. AB is 28. GH is 49. And BC is 16. And HJ is 28. Okay, so let's see if they have any things in common, right? So between 28 and 49, I think they have a common factor of 7. 7 goes into 28 4 times, and 7 goes into 49 7 times. So it has a ratio of 4/7. And what about 16 and 28? Well, 4 goes into 16 4 times, and 4 goes into 28 7 times. So this is 4/7. So this means, yes, they are similar. So right now, this triangle is similar to this triangle, and it's also similar to this triangle here. So now we just have to see if this, did I say triangle? I meant rectangle. This rectangle is similar to this rectangle, and this rectangle is similar to this one, right? So now we just need to determine whether this rectangle is similar to this one. So let's start with the, and I kind of feel like it is, because we have 28 over 28, right? Let me get a different color. Let's go with green. So we would do the long side, which would be AB, over the long side here, which would be NO, and then the short side is BC, over, oops, sorry about that, the short side is MN. Then we substitute in the values. Okay, so AB is 28, NO is 28, BC is 16, and MN is 16. So 28 divided by 28 is 1, 16 divided by 16 is 1, so yes. Okay, this means they're all similar to each other, right? So since this is similar to this, and this is similar to this rectangle is similar to this rectangle, they're all similar to each other. So we're gonna say A, B, C, D. Okay, so I'm gonna say, rectangle ABCD is similar to rectangle, and I have to line it up right. So I started here with A, so I'm going to go here with W. WXYZ is similar to rectangle. So what did I do? I went AB. So let's go GH, GHJK, which is also similar to rectangle. So we started with A, this side of the 28, the long side, and then we went here. So it's going to start here and go ONMP. ONMP. So all of the rectangles are similar to each other. That's so cool. Because they all have the same angles, right? And then they all have equivalent ratios. So for their sides, corresponding sides. All right, well that is it for example 1. I'll see you in a little bit for example 2.